Jabber protocol parsing, which has now been fixed. But so here's kind of the bottom of it, right? We have this new session being defined. I'm specifying the file name to store the session information to. I'm instantiating a new target. So this is the IP address and the port that we're going to be fuzzing. And then we have, I'm creating 3 agents. I'm saying the netmon, procmon, and VM control. Here's the host that they're at and the ports that they're listening on. Those are all default values, the 26,000. Then we are starting up the target. So I'm saying target.vmcontrol.restart target. So it's actually going to bring up this virtual machine where I've previously saved or taken a snapshot, running a snapshot. I'm adding the target to the session. I'm saying before you fuzz anything, you've got to send this pre-send init message. This is where I'm doing the actual graph. In this case, it's a single request, so there is there's not multiple nodes. And I'm saying connect the root node to sget is going to pull the request chat message out of the library, which I've defined earlier. And then just session.fuzz. At the top, you'll see we're importing Sully from the request library, we're importing Jabber. And here's the function that was defined to do the initialization. All it does is it's going to send this very simple XML packet, because you can't begin to communicate with Trillion Jabber unless you send this initialization vector. So I didn't want to fuzz this, so just made this a static, do this before you start fuzzing the next request. So fairly simple, fairly straightforward. The next thing is these command line utilities. And since we're somewhat might be getting tight on time, let me do this Crashbin Explorer demo real quick. So the Crashbin Explorer is what you use as a command line utility to actually explore the Crashbin that, what's it called, to save. So we're going to this utils directory, and I've got this Crashbin Explorer. So I'm going to give it a path to, for example, our saved Trillion audit. Why is that? Archive fuzzies? Yeah, that's for stuff that you've finished. Man, I can't see it on the screen. Hold on 1 second. All right. So this is the actual Crashbin from the fuzz on Trillion, and you can see that there was these are all the fault points and the test case numbers that cause faults at that point. And so one of the cool things that we can do with this next is we can graph this thing. So you can't read it, but I'm adding a -G and whatever, just test. So I'm going to create a graph, and I'll start that up. It's being rendered in UDraw. And so this graph shows all the fault locations, just like the Crashbin did, but it pulls on the stack backtraces to kind of pull it back to a single fault place. So we had 3 faults that occurred at this address, 2 at this address, 24 at this address, and 1 at this address. But because we can see it in this graph format now, we can go up and we can see they actually all started from the same location. And this actually was very helpful because it's not that I found 30 different bugs. It was a single bug. It just kind of presented itself in different areas of the binary. So, again, not to pick on Codenomicon, but, when we were doing one of our first VoIP tests with it, we had something like 2,000 crashes. And it was 1,996 crashes because of one format string that was really, really low level and was getting hit all over the place. And then it was 4 other issues. So we had to go through each one of these things to make sure that we weren't missing a bug. And, because we're not the developers, we can't just fix the problem and go retest. It was really painful, and I'm sure my guys hated me for it. But so now if you have this kind of tracking, what we would have seen is just 4 paths, 1996 faulting on one position, and then 1 for each other fault. Oops.
So the next utility is we call it the IDA fuzz library extender. This is an IDA Python script, and what it does is you run it from within IDA, and it's going to rip out all static comparisons. So if it's a compare register immediate value, it's going to rip that out. If it's a string compare, so I go through and spider all the Y character string compares and all the other random string compares that are part of the Win32 API and others, and it takes all of those and adds them to 2 files in the root Sully directory. So when you actually start fuzzing, it will the fuzz library for integers and strings, it'll append all the values that this enumerates for you into the fuzz library. So it's kind of like, it makes it a little bit smarter. And this has helped in a few situations where there's a magic value that you haven't found through reversing it. This will be able to pull that out, and it'll actually add it to the library, so you'll have a better chance of actually hitting that and passing certain tests. I'm going to do a quick demo of it.
I'll just run it real quick.
Yeah. So this is the HP bug. which still isn't.
This is IDA. This is an IDA Python script. You launch it, you tell it where you want to save it to. And one of the benefits of having this is, let's say you want to add target-specific strings and integer types, but you don't want to extend the library. You just want it for a certain target. Well, you can save that .fuzzstrings, .fuzzint only for trillion or only for HP. Kind of pull it off into the archive fuzzies when you're done with it.
Right, and you'll see here, these are all the integers that it discovered, and these are all the strings. As you'll notice, there are a lot of nulls, which is Unicode, because most of this process deals with Unicode, and therein lies the bug, actually. But some of these values are actually useful. They're the magic values that you need to actually get through and pass certain checks.
Yeah. I'm going to skip this PCAP cleaner. We'll skip this one. All right, so we're going to do 2 demos. You can do your HP one first.
All right. First thing we're going to do is a bug in Hewlett-Packard Data Protector. So we already have the image set up. Okay, so this is a VMware image with the software installed. We have an installer for Sully. I'm just going to show you the first page of it. I'm not actually going to install it because I've already done so. But it's just a nullsoft scriptable installer, really easy. Yes, go away.
It's probably the number one complaint I got about PyMA is that installing it is a pain in the ass.
Which is why I wrote that thing.
So now, my response was, I don't care.
Right. So now we're going to go into the Sully directory itself, maybe. Okay. Going to fire up the network monitor, which is going to save all the PCAPs for everything we're doing here. And we're going to start up the process monitor and attach to the process that we want to deal with. So the process monitor is going to take a crash bin file name. I'm just going to call it HP. Process name, in this case it's on the iNet. And we're going to set it to log level 5. So now that's going to sit there attached to the process and await requests. Next thing I'm going to do is the network monitor just to sniff all the packets. Choose interface number 1. Filter is going to be source or dest port 5555, log level 5. Okay, so now everything is set up here.
Switch back to that one real quick. Let's just make sure it's on there. Cool.
Yep, looks good. At this point, I'm going to take a snapshot of this VMware image so that if a fault does occur, it's going to revert back to here, so we'll be good to go again. So we're just going to take a quick snapshot, call it Sully good to go. Okay.
And on this whole health restoration thing, so this was just a typical problem. Like, let's say you wrote a spike script and you want to run overnight, find you faults. Well, maybe 2 hours into your sleep, it would have found a bug, and then it just stops. It just sits there. So what we want to do is we want to take advantage of all those nighttime hours. We want to constantly be fuzzing. So in the event that you do have a virtual machine control, it will revert to that known good image, and obviously it's restored to good health. If you don't have that, but you've got the PyDebug control attached to it, it can restart the target service. So you can give it optional arguments like netstop x, netstart x. And of course, if neither one of those two are available, we can fall back to the ultra crappy, just wait for it.
Okay. So now that that's all set, it's running. Should I power that down? Okay. Now we're going to run the VM control. And this, I guess I'll show you guys. It's just interactive mode, which lets you do this fun stuff. You just need to point it to your VMware directory so that it, I can't see. There we go. And to your image itself, which I'll just do over here. In a minute.
Yeah. So the virtual machine control is outside of the environment. The PyDebug has to be inside. The network monitor could be either. Currently, in this case, we just put it inside.
All right, then you got to give it the snapshot name where everything is good. So we're going to call it good to go. And the log level. So now this is ready to go. And we're going to fire up our driver script, which is fuzz data protector. So while that's going, I'm going to quickly show you what that file looks like.
Show the web interface real quick, too.
Okay. The web interface. This will come up once once everything attaches here.
Yeah. So what's going on is it's going to instantiate VMware through VMrun. which can take a little while. And then it's going to, all the stuff is synchronized. It's just the fuzzer is waiting for the image to come up, then it's going to wait to get a ping back from the debugger and the net monitor saying everything is good. And this is going to start fuzzing. So say, okay, guys, test case number 1 is coming. So netmon, you need to start recording. Procmon, you need to start recording. The code coverage monitor, you need to start recording. And then if there's a fault that comes back from the PyDebug script, it can say, okay, VMrun, you need to restart. Or
no, that's not. That's from later. That's from earlier.
Is it not coming up? Oh, demo gods.
Yeah, I knew this was going to happen.
Well, let me do mine real quick then. Oh, wait, is it working?
Let me just kill this and restart it.
The laptop respects me. Let me get my hands on it. It knows who it belongs to. While that goes on, we can just show this, which is...
Yeah, this is the actual... that's the driver, which you just set up the session, you point it to the actual process and the port and all that, and set up your agents. And this itself is the actual protocol. I just wrote a quick little custom encoder, which is that Unicode function right there, which just splices in nulls to whatever string that you give it. And here's the actual protocol. So it has one packet, which is the... it's just one packet just telling the process the size of the following packet. You got to restart this. Which is why we use the sizer for that part. So it's just a sizer saying the next packet is going to be the size of block number 2. And block number 2 is where the actual protocol is defined. And this protocol is fairly simple. It's just going to be a byte order marker in Unicode, which is FEFF, and then it's going to be a few Unicode things. You just have to give it a few Unicode numbers to pass checks to W2I functions. And if you get by a few of those, I think there's 3. There's one magic value, which is a D word, which is the IDA file fuzz extender will actually pull out for you. And the last thing that you do is just a huge buffer, which overflows a wide character string copy. And this process itself probably has about 15 more bugs in it that I haven't actually tried to fuzz out. So, happy hunting.
Where's the hammer?
Yeah.
If this doesn't work, I'm smashing the laptop. There we go.
There. All right, now it's working.
So it's restoring the...
So the VM control is starting back up the image to the good to go, and the fuzzing should be starting. If you go back to the console, you'll see it.
Well, yeah, so you can kind of see the debugger thread just kicked off, and there, this was just informed, hey, you need to start recording. And then the fuzzer is starting to transmit. So it'll tell you the current path, what it's sending, how many bytes are captured, et cetera. And now you can kind of see this web interface. Oh, we forgot to, of course, clear out the session. So,
well, this is our previous session. You'll see that there's some exceptions shown below. Those are from our testing previously, and I didn't clear out the session file, so it's just resuming where I left off. But you'll see that there's invalid 33333, so that's EIP, so it's a Stack Overflow that smashed a bunch of stuff. You click that, you'll see the context data. It gives you a ridiculous stack, and the SEH unwind is at the very bottom of this.
Yeah, the process is definitely not happy.
Yeah, this thing got screwed over pretty badly. I mean, you can basically copy the entire size of a packet that you could possibly send over the wire into a, I think it's like 268 byte stack variable. So you can smash stuff pretty well in this.
So this will, the nice thing about this is now we can just leave. Like, we'll set this up on a Friday afternoon. We'll leave for the weekend, and when you come back, it's gone through everything. It's exhaustively recorded every single packet capture. It's recorded every single crash, and it'll tell you, what it's gone through, where the faults are. It's got the crash bin, so you can explore it with a graph. All these other aspects.
That's definitely the beauty of it, that it's completely autonomous. So you set it, say go, exceptions will occur, it'll revert, it'll continue. And if you don't have VMware and you don't have the latest version that has that API exposed, you can use our